All right, let's get right into it. Today, we are tackling one of the most misunderstood, most frustrating parts of being a web developer, CORS. Seriously, if you've ever built a web app, you have slammed into the wall that is a CORS error. And in the next few minutes, we're going to tear that wall down and demystify it for good. Because it feels just like that, hitting a wall. You know the feeling. Your code looks perfect, you make a request to an API, and boom, the whole thing just grinds to a halt. You're completely blocked by this mysterious gatekeeper. And the error message it gives you? It's famously unhelpful. Ah, there it is, the classic, the infamous cross-origin request blocked. I'm pretty sure this single line is responsible for more collective developer frustration than almost anything else. But what if I told you this isn't a bug? What if this is the web working exactly the way it's supposed to? Now this right here, this flips the entire problem on its head. Most of us think CORS is some server-side headache that we have to fix. But the truth is, CORS is a security feature that's enforced by the browser to protect your users. Your server is totally fine. You can hit it with a curl request all day long, and you'll never see a CORS error. This is 100% about browser security. So to really get CORS, we have to take one step back and talk about the fundamental security rule that governs the entire web, the same origin policy. You can think of this as the web's default out-of-the-box security setting. It's locked down tight.
The whole policy is built around this idea of an origin. An origin is basically a website's unique address, and it's made up of three very specific parts: the protocol, like HTTPS, the domain, like app.com, and the port number. If even one of those three things is different, the browser considers it a completely separate, unrelated website.
Let's make this real with a few examples. As you can see here, https:/app.com and https:/api.app.com are not the same origin. Why? Because the subdomain is different. Same deal for HTTP versus HTTPS. Different protocols mean they are different origins. To the browser, these are complete strangers, even if to us they feel like part of the same family.
So why be so strict? Well, imagine you're logged into your bank account in one browser tab. Then, in another tab, you accidentally click on a malicious link. Without the same origin policy, JavaScript on that evil website could just make a request to your banking site, piggyback on your logged-in session, and start siphoning off your private data. The SOP is that digital wall between your browser tabs that makes sure that can't happen.
But of course, the modern web is all about different origins talking to each other, right? Our front end at app.com absolutely needs to get data from our API over at api.app.com. And that is where CORS comes in. It's the official, secure way for a server to poke a hole in that wall and give another origin permission to access its stuff.
Just think of it like this. CORS is basically a system of permission slips. The browser sees your code trying to make a cross-origin request, and it pauses. It goes to the server and asks, "Hey, this website over here wants to read your data. Is that cool?" The server then responds back to the browser with a special header, access control allow origin, that says, "Yep, that specific website is on my guest list. You can let them see the response." The key here is that the server is the one in control. The server grants the permission.
Okay, but it gets a little more nuanced. The browser doesn't just treat every request the same. It actually divides them into two main buckets, what it calls simple requests and preflighted requests.
Simple requests, like a basic GET request, are seen as pretty low risk, so the browser just sends them right away. But more complex stuff, requests that could actually change data like a put or a delete, or requests that have custom headers like an authorization token, well, the browser sees those as potentially dangerous. So for those, it takes an extra security step.
And that extra step is called a pre-flight request. It's like a bouncer at a club. Before sending the actual data request, the browser sends this tiny little options request first. It's basically tapping the server on the shoulder and asking, "Hey, I'm about to send a delete request with this custom header. Are you cool with that?" The server responds with the rules of the club, which methods and headers are allowed. If the browser's plan fits the rules, then and only then does it send the real request. If not, it's blocked and you get that dreaded CORS error. Now, this gets super important when you're dealing with authentication. If your request needs to send credentials like a session cookie or a bearer token, you have to be really explicit about it. On your front-end code, you have to literally set credentials include, and on the back end, the server must respond with the specific origin, no wildcards allowed, and it has to add the header access control allow credentials true. It's a very specific, explicit handshake of trust.
And this brings us to a huge, critical mistake that so many developers make. You can never set access control allow origin to the wildcard star, STAR, and allow credentials at the same time. Just think about what that would mean. It would mean that any website on the entire internet could make authenticated requests to your API on behalf of your users. That is a gigantic security hole, and because of that, browsers are literally hard-coded to reject this combination. Always. It will never work.
So you see, getting this stuff wrong isn't just about your app not working. It can lead to some really serious security vulnerabilities. Let's look at a couple of the most common traps people fall into.
A classic mistake is something called origin reflection. That's where a server is configured to just blindly trust the incoming origin header and reflect it back in the response. This completely defeats the purpose of CORS and lets any attacker's site steal user data. Another trap is using whitelists that are too broad. Sure, allowing star.example.com might seem safe, but what happens when an attacker finds and compromises some forgotten subdomain, like oldblog.example.com? Now they can use it to attack your main application.
So here's the big takeaway from all this. CORS is not just a line of code you Google and paste in when something breaks. It is a fundamental part of your system's architecture that you have to plan for from the very beginning.
You know, in a modern microservices world, the absolute worst thing you can do is have every single little service trying to manage its own CORS policy. It becomes a total nightmare to maintain, to audit, and to keep secure. The right way, the sane way, is to handle CORS in one central place, at your API gateway or your reverse proxy. This gives you a single, consistent security boundary for your entire system.
Look how clean this pattern is. Your front-end app, living at app.com, makes all of its API calls to the same origin, something like app.com/API. The API gateway, which sits at that address, gets the request and then figures out which internal microservice to forward it to. From the browser's point of view, no cross-origin request ever happened. The whole CORS problem, it just vanishes.
Okay, let's nail this down. Here are the key takeaways. Number 1, CORS is a browser security feature designed to protect your users, not your server. 2, you have to treat it like an infrastructure policy, not an application bug. 3, the best place to manage that policy is centrally, at your API gateway. And 4, never, ever, ever blindly trust the origin header that comes in with a request.
If you only remember one thing from this whole explainer, let it be this sentence right here. This is your perfect interview answer. CORS is a trust contract enforced by the browser, where your server explicitly names its trusted partners. And architecturally, that contract belongs at your system's front door, the API gateway.
Once you really understand that CORS isn't a bug you need to fix, but a lock that you need to configure correctly, everything changes. You stop being a frustrated developer and you start thinking like a security-conscious architect. So the question I want to leave you with is this. Now that you know how the lock works, are you sure your application's front door is locked correctly?